Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Good afternoon. My name is Bobbie Stempfley, and I'm the CERT Director at Carnegie Mellon University Software Engineering Institute. It is my pleasure to have you here today for a podcast with one of the pioneers in cybersecurity, Steve Lipner. He is currently the Executive Director of the Software Assurance Forum for Excellence in Code, known as SAFECode, a not-for-profit organization dedicated to increasing trust in information and communications technologies, products, and services through the advancement of effective software assurance methods. Before he retired a few years ago, he was a partner director of software security at Microsoft and the creator and longtime leader of Microsoft's secure development lifecycle process. He's also the chair of the U.S. government's Information Security and Privacy Advisory Board. You're a very busy man. Thank you for joining us today, Mr. Lipner.
It's Steve. Steve is fine, Bobbie, and thank you for having me. It's a pleasure to be here.
It's really great to be reconnected.
Yes, indeed.
I find the culture of computers and information technology changing so rapidly today that sometimes we find it difficult to get our grounding. And you've always had your grounding. And this podcast is really about exploring the lessons of the past and how we can apply them to the future so that we're not recreating problems. And I think you've got such an important story in this space. You're hyper-focused on software before many others did. And so I really look forward to hearing from you today the kinds of issues that you've been working.
Thanks very much, Bobbie. It's a pleasure to be here. And as you say or as you suggest, spent a long time worrying about different instantiations and manifestations of how do you build secure software. Finally, got into a position and an approach that we think actually made a difference. And I'm really happy to have had that happen in time for me to see it come to the fruition it has.
So I want to spend a little time exploring that, but first, can you tell me about SAFECode? What are the problems the organization's working to solve?
So SAFECode has been around since about 2005 or 6, and it's a nonprofit. It's an industry nonprofit. The members are companies that have to deliver secure software, big ones, small ones, online service companies, packaged software companies, and some that are manufacturers that include software in the devices or products that they build. So quite a wide range. But everybody bound together by this challenge: how do we deliver secure software? How do we deliver secure software better? How do we get the software we depend on to be secure so that we're not challenged by supplier problems, and how do we enable the rest of the ecosystem and the industry to understand what effective and less effective approaches are.
So it's a community of the willing to some extent, people who are invested?
It's a community of the willing to some extent. I mean, we're a small organization. The products and guidance that we produce are created by the effort of members, employees who band together and work to share their experience and then deliver a common picture of what organizations ought to be thinking about doing as they tackle software security. We started out producing sort of heavyweight documents that took a long time to deliver, and there are still some of those, very valuable on the website, fundamental practices for secure development, dealing with third-party software, how to do threat modeling, or some of the recent ones. But more recently, we've focused on trying to be agile, and so now we're trying to build smaller products that we deliver in the form of blog posts. We did a series of blog posts on building a security champion program, for example, at the beginning of last year, and like half a dozen blog posts over the course of a month to enable anybody who wanted to say, okay, what is a security champion? Why do I want one? And how do I get started rolling that out in my company?
So would I be wrong to connect this idea of a security champion to the role you had at Microsoft in trying to gain advocates to push a secure development lifecycle?
It's a little different.
Okay.
I was leading what we'd call the central security team, the central secure software team, that sort of defined the tools, set the process requirements, manage the training, what have you. Security champions are people in a product group who are focused on enabling that product group to deliver secure software, whatever that product group delivers, whether it's a Windows or a database system or an Adobe Reader or what have you. There'll be security champions in the product group, engineering group, who are the sort of local go-to experts, local advocates, local interfaces to the broader security program. So that's a very common model in industry, and it's worked out very well for a lot of companies.
So in a Microsoft context, those would be the people you would have worked with in the product lines that are there.
In Windows, in SQL, in Office, and so on.
So can we talk for just a few minutes about what your catalysts were at Microsoft for trying to step into these security pushes?
Well, sure. I mean, back in 2001 particularly, there was just this series of security incidents, or maybe if you want to call them security flaming disasters, that's okay too. The Code Red worm, the NIMDA worm, the UP&P vulnerability in Windows XP, which turned out not to be a big deal, but it got a lot of press. And in parallel with that, customers were yelling at us and yelling at our executives. And actually, at one point, Gartner published an advisory that said, gee, if you're running the Windows web server, IIS, you might want to think about changing to another product. And so that's sort of an attention getter. And internally as well, I mean, people at Microsoft took a lot of pride in their work. They wanted to be an industry leader, a technology leader. So, all those things came together and really sort of said, we have to do something.
Yeah, I was on the operations side of Code Red and NIMDA and others in an ops center responding. So I was certainly personally particularly thrilled with the idea that you were trying to change some of the structure and culture in one of the big product lines that was out there. So how do you it strikes me that you've always been an outcome-driven person, and I think about measurement in this space, right? How did you measure success in Microsoft as you were taking this on, and how do you think about that today?
So there were a couple things. I mean, you want the product to be more secure, but we don't know how to measure that directly. And in fact, I was talking to a professional colleague, pretty well-known vulnerability researcher, about some of our efforts over the years. This was probably 4, 5, 6 years ago, and he said, you guys have done a good job, and I know you've done a good job because the free market price of a Windows zero-day vulnerability has gone way up from what it was 10 years ago. And so, that just to me, I mean, he's absolutely right. And it is a metric. It's an outcome-driven metric. It's not one we can could cook. But how do you, short of that, how do you measure? What we did was really two things. Number one, the requirements that we put in our secure development processes were really driven by experience of vulnerabilities. So, how do people attack our systems successfully? And then those requirements are explicit enough so that you can tell very clearly whether the product team has in fact met those requirements. I mean, if you look at the copy of Microsoft SDL version 5.2, that's a free download on the web, and you look somewhere, I think they may be in the appendices, but there are specific static analysis tool bug numbers that are must fix. Okay, and so that's measurable. It's cheap to measure. You run the tool and it tells you.
Mm-hmm.
It's cheap to measure whether you've gotten all of them. You just do a query in your bug tracking system and it'll tell you. And so that's meeting the requirements. And then the requirements to actually improving security, that's driven by experience with vulnerabilities and experience, having to fix or not fix vulnerabilities going forward.
The interesting thing about those two examples, and I think one of our struggles in measurement, is that on one hand, your requirements, you can the people doing the measurement have the ability to see the link between their action and their result, mm-hmm. and that outcome measure, you can't. That's measured by someone outside of the organization. That it's a really useful outcome measure, but bringing it back in and showing what actions complied. That's sort of the gap today. So
you can say, well, there's some sort of an integer overflow that somebody, attack, vulnerability, somebody's going to write an attack and exploit it, and some terrible thing's going to happen. So if I had only just fixed that one, then things would have come out much better. But you can't, in the security world, you just can't attack it that way. Michael Howard, who co-wrote the SDL book with me and one of the key developers of the SDL at the beginning, he used to say, just fix it. Not a matter of trying to second guess whether somebody can exploit this, not a matter of trying to second guess, whether it's really a vulnerability or not. If it violates the requirements, just fix it, and then you won't have to worry. Because probably, if you try to guess whether it's exploitable or not, you're going to guess wrong.
And at some point, the energy spent to that could be better applied to just
for sure.
the fixing it
for sure.
in that space. So you've said that security assurance has been the most challenging topic I've had to contend with in my 45 years working on computer security. Why? And how have you thought about where we are relative to methods and processes and formal validation?
Well, so why is it challenging? Because it's really adversarial. I mean, it's really an emergent property of systems, and so you don't have a clear definition of when a system is secure in general. I mean, we back in the 80s, A1 Systems Orange Book,
right.
We tried doing mathematical models, and the mathematical models that were tractable enabled you to build a system that wasn't usable and nobody wanted to buy.
Right.
And so that wasn't very good. And so, what we do, instead is really just to try to say, okay, be driven by reality. Rick Proto, who used to be the tech director for information assurance at NSA, used to say, theories of security come from theories of insecurity. Start from how people attack systems, and then take that class of attack and frustrate it. Take another class of attack and frustrate it. Take another class of attack and frustrate it. Somebody comes up with a new class of attack, you'd rather they didn't. That's okay. Understand it, frustrate it. Best case, your good guys, the red team that works for you, comes up with a class of attack, and you frustrate it, and nobody never knows it was there. We actually had one fun case, 2005-06, where some of our really brilliant security researchers internal to Microsoft came up with a class of attack that was really pretty bad, pretty pervasive, and then they built a tool that enabled us to find violations of instances of that vulnerability, and we made that tool mandatory under the SDL. And starting with Windows Vista, we just wiped out all cases of it, and nobody ever knew. If somebody, maybe for its 20th anniversary, I'll get them to publish a paper. But it doesn't matter because there's no system in support where that vulnerability still lives.
Yeah. So that's a beautiful, perfect case, isn't it? Right, in terms of how
it is a beautiful, perfect case.
Everything.
But that's what you're trying. That's what you'd like. But you know that case has happened occasionally.
Right.
Now how do you replicate it?
Right. What are the circumstances that enabled that to happen, and how do you create those? So the interesting thing, I'm struck by your language, right? Find a category of attack and frustrate it,
right,
compared to this idea of formalism, right? Frustrating is not as precise a, perhaps it's just you've put so much sand in the gears that you've moved beyond, the adversarial moved beyond, compared to what's the level of formalism that that verifies that you're not going to have something. Was that intentional?
Probably not that intentional, but it's probably not a bad model. I mean, one of the things we do is to try to remove, vulnerabilities, instances of vulnerable code when we find them. We know we're not going to do a perfect job of that. So some of the other things that we've focused on are what we call mitigations. Basically, sort of an old example is, 15 years old now, I guess, the non-executable stack and heap memory.
Right.
Okay.
I very much remember this.
The overruns, the errors are still there, but you can't exploit them, or at least you can't exploit them as easily. And some of the Microsoft, some of the SAFECode members have done a lot over the years with trying to follow that philosophy, not as an alternative to writing secure software, but as a complement to writing secure software.
Right. Yeah, it's the interesting thing to me about that example and the idea of as a complement to secure software is the software gets you so far, and then at some point the platform has to pick up, and that how you mitigate the gaps that are caused in that transition. I think that example is a good one. There. Last year, at Usenix 2019, you said that a big lesson you learned from the rollout of the SDL is that secure software depends on, I'm going to get this right, enabling secure development rather than measuring security compliance. We keep trying to compliance in security. How do we think about, how does your experience help us think about not taking that tact in the future? Is there some lesson from that we should?
I think there very much is, and that really sort of goes back to the history of the Windows security push. Okay, we, at the time of the Windows security push, my team, that was sort of driving the security push, was like 4 or 5 people. Okay, 8,500 Windows developers. Okay.
Yeah, the numbers didn't.
Right. We're not going to review all the code and find all the security bugs, although I think that was a model at some point before I joined that team. But, what you can do and what you have to do is to motivate the developers to write secure software, train them on what that means, and then set them loose to doing it, and provide tools, training, process, best practices, and advice when they need it. And that's a scalable approach. If you say, I've literally seen companies I think all our SAFECode members are past this. Literally seeing companies, where they have a security team that they say they have a security development process. They have a security team that comes in after the software is done, and then they code review it, or they run their tools, or they penetration test it, and then they find bugs, and then they pass them back to the developers after the developers thought they were done.
Right.
Okay? And so, the developers hate that because they thought they were done. Managers hate that because they thought they were ready to ship. You wind up making, quote, risk management decisions, which too often mean, well, I can't afford to fix this. I'm gonna ship with it. And so, that's my model of what a compliance-driven software security program looks like, and it not so good. In comparison, even the Windows security push, we trained people, we gave them tool outputs as they were doing development, and so they knew what bad code looked like. They knew how to replace it with good code. If they came up with an edge case, they had somebody knowledgeable like a Michael Howard to turn to. And at the end, we didn't have a perfect product, but we were close enough so that we could ship something that was a lot better than what we started with or what the prior versions were. And so that's really my view on compliance. I mean, you still can measure, but the measurement ought to be pretty easy because the requirements are pretty explicit, and the tools tell you, and the tools and testing tell you, very precisely, what you shouldn't have done, and if the tools and testing don't find anything, then you've probably done a pretty good job.
So one of the things that Dr. Michael McQuaid, the Vice President of Research here, did in his work with the Defense Innovation Board is cause DoD and others to think about software in different categories, right? Mm-hmm. Safety critical software is perhaps different than not safety critical mm-hmm. software, and apply different methodologies perhaps to those two. Is that a strategy that, how do you think through that relative to this? It strikes me that while the requirements are going to be different, in the end, the methodology might be somewhat the same.
Well, I mean, so you may, for something, security critical, protecting the nation's most sensitive secrets mm-hmm. from the internet, maybe you're willing to pay the price of doing, the sort of compliance right. thing and the post-testing. But for an awful lot of systems, most systems, and most software that runs anywhere, where people consider their information important or private or sensitive, you really have to do a base level of secure development, because what we've found is that, vulnerabilities in odd places can result in bad consequences. So I think that one of the challenges is we would really like to see secure development processes, secure development practices be pervasive or universal or as close to that as we can get them.
How we write software has changed so much in the last, I know from when I learned eons ago. And so how do you think about what tooling or what's important for developers today in how software is developed today? Is there some?
The main thing. Well, so one of the challenges. When we created the SDL at Microsoft, we worried initially about C, C++, and C#.
Right.
The three sort of common languages internally. Today, many organizations that are doing development, are dealing with 8, 10, a dozen, 20 languages. And you have to do secure development in each of those. Mm-hmm. And so, I talk a lot about scaling. That's a problem that really kind of poses a scaling problem. The more languages and frameworks you're dealing with, the more different secure development tool sets and standards and practices and training you're going to have. And if you're a small organization dealing with 20 or 30 languages or frameworks, that can get, overwhelming, challenging. It's a problem. But there's not much of an alternative. At least, we're starting to see the emergence. There are static analysis tools, code analysis tools, best practices, testing, things that individuals and organizations can pick up and learn and apply. But I'd say the diversity of languages and frameworks has not made our lives easy.
Yeah, the cost of sustaining multiple code trees is really high, and then to think about sustaining multiple infrastructures to support all of that. Within that, is there a set of tooling that you'd still like to see that is sort of still necessary?
Well, you always, the big things, for secure development are, I just think about it. The things that we talk about, just in sort of the canonical SDL model, if there is such a thing, are threat modeling, which is really a design analysis technique, static analysis, and more generally secure coding practices, dynamic testing, fuzz testing, if you're in the C++ world, but dynamic testing in general. And then the last, I think, is configuration testing, basically just to make sure that the files and objects that you lay down are protected properly in the environment or on the system. And those are sort of general, and then you kind of have to specialize them for environments. If it's Linux, it's different from Windows. If it's Python, it's different from C++.
Yeah. So the interesting thing to me is this idea that kind of infrastructure and tooling is a different model than that which some people have of anything can be written in anybody's basement, right? And so this idea of really thinking through your design analysis and infrastructure.
Yeah. And it can be affordable, but if you ignore that, that's a significant risk. One of the other things that's changed a lot today is the dependence on third parties, dependence on open source. Basically everybody uses open source. Everybody uses third-party components, and so what's the assurance of secure development of this thing that you copied, off some repository in GitHub? What's your standard for deciding whether to accept that or not? What to do. SAFECode third-party components document that we released just a year or two ago talks a lot about best practices for third-party components, but ideally you'd like your third-party components to be written to as good a secure development process as you have yourself. It's not always the case, but that's what you'd like to aim for.
Yeah, the supply chain has gotten much more complicated,
Yep.
Both in terms of what you're getting, where you're getting it from, how much transparency is or isn't in that supply chain, and so I think about that a lot. We think a lot about that. One of the things that I find really interesting is this push for speed. Right. I think speed changes security a little bit in terms of how long something might be at risk. And so how do you think about what we're doing with Agile methodologies and DevSecOps and how that aligns with the the work you're doing in software?
That came up. I had to face that actually with the MSN group at Microsoft, because they were, we'd come out with this SDL thing, the Secure Development Lifecycle, and they said, well, that's all very well if you're doing a Windows release that's going to ship in 3 years, but I'm shipping this afternoon. What, it just doesn't work for me. So we had a program manager named Brian Sullivan, who knew a lot about Agile development, knew a lot about the SDL, and he sort of thought about it, and he enabled us to sort of take the things that we said you had to do, and then parse them up. So there are some things, if you're, you're shipping this afternoon, that's fine, but your code still has to run through your compiler tool chain before it gets deployed. So there are some security measures, some tools that can just be integrated into that tool chain and their SDL requirements. So you just meet those as you go every time you ship. There are some, if you're doing the broad architecture, the design of a system, maybe that's something you're doing at the beginning of a project, and then it's only a major rev where you reconsider that. So if your threat model, you do that once, probably got a threat model that's good for a while, and it sort of tells you what to do as you go. And then finally, there's some kinds of testing that you have to run that take a while to do, and maybe you do those periodically rather than doing them, doing 3 days of testing every afternoon. And so, you take a little risk before the next test cycle completes, but if the test cycles are ongoing, it's not a huge risk. And overall, that process was how we tackled Agile security for the Agile development cycles, and that worked out pretty well for us. And I think probably that same model applies even DevOps, DevSecOps, what have you. Mm-hmm. If you just think about parsing things out that way.
Yeah, the interesting thing to me is the potentiality with all the tooling today to get data that can then be used, and you can push your risk management earlier in the process. Mm-hmm. You can push your security arguments earlier in the process. You can push your validations earlier in the process. Yeah. And as you can speed up the release of hopefully ever improving quality and assured software, you can change a bit of the dynamic.
If you can get the tools, and if you can integrate them into your developer desktop or development chain, then that's a great way to get the assurance up and the residual vulnerabilities down.
And it'd be interesting if we could get to a point where your third-party software has some data from its tooling about it that you can then incorporate. Right? There's a little bit of a vision out there that we're all working towards.
That would be a great vision if we could realize it. I'm sure a lot of organizations would be very happy to know that some coding best practices, that some static analysis had been run on the third-party components they were consuming.
Yeah. And I think that's some of the software bill of materials activities, trying to see, at least knowing what's in there, and then the next step about, could you put some details about the what the quality standards of the thing and others.
I've been a little bit of a skeptic on the software bill of materials. I think it is super monumentally important for developers to understand their bill of materials and what they're using. When people say, end users need to understand the bill of materials, I sort of ask why and what are they going to do with it. I mean, that's sort of a harder case.
For me, the utility is in the architecture and the design and the implementation at the development stage. I hear your comment. So one last question. Mm-hmm. What do you know now that you would have liked to have understood much earlier?
Oh, gee. So I guess what I need what I know now that I would have liked to have understood much earlier is that, getting to secure products, getting to software security is really a matter of continuous improvement and root cause analysis, rather than trying to build the perfect model and then work for decades to implement it. There are cases where I've tried the perfect model and it didn't come out so well. But and there are people who still believe that that's what we ought to do, and in another 10 years it'll all be nirvana. But I think if I can do continuous improvement for 10 years, things will be a lot better.
Yeah, it's thematically, right, it's a culture change question. I've heard you say, I think I also heard you say, hit the point of best impact for intervention, the developers on the software. Think about good design patterns and threat modeling and other approaches to do it, and constantly improve as you're going along.
Constantly improve. Every vulnerability report, you take a vulnerability report, you do a root cause analysis, figure out why did that happen, what can I do, not just to fix that vulnerability,
right,
but to fix it and all its friends and relations. And you just keep cycling that, and over time you just turn the knob up and up and up.
Right, and frustrate that situation. So ultimately, culture change is a big issue for security, and it strikes me that the work that you took on at Microsoft, and you and I met, I think, the first time when you had just come to Microsoft and I was still in the DoD. How can we change this corporate culture to focus on product security? How did you go about that?
So for us at Microsoft, the big turning point were two things. One of them was all the problems we had in 2001 that we talked about, and the other was the trustworthy computing commitment, the trustworthy computing email that Bill Gates sent, and that was a combined project of Bill and Craig Mundy, who was one of our CTOs, and the late great Howard Schmidt, who was my predecessor at SAFECode, and at the time had been the chief security officer at Microsoft. The three of them, Howard and Craig, really pushed, encouraging Bill to create the TWC commitment and make that part of the company, and that sent the message across Microsoft and to the working level developers. This was something we were serious about. Other thing, sort of an interesting story about that, we, as part of the, starting this Windows security push and doing the focus on Windows Server 2003, we trained everybody. We had a room that held 1,000 people. We trained them in blocks of about 800 or 900, 10 times, 10 sessions over the course of a week, 4-hour sessions. And for each of those sessions, we had a corporate vice president, one of the intermediate level managers in the Windows division, come in and introduce the training. Okay, and if you've done corporate training, you know how that works. The corporate VP comes in, introduces the topic, tells you why it's important, and then leaves. Okay, in the case of the Windows security push training, corporate VP came in, introduced the topic, told you why it was important, and then sat down to take the training.
Oh, wow.
And that's a message you don't see in companies very often. It kind of tells you what's important and what's not. And I think that worked for us pretty well, too.
Yeah, so allies from lots of places really pushing forward, and corporate leadership
people's
attention.
VPs, these people's managers, this is important enough for me to spend 4 hours of my time learning it. Maybe it's important enough for you to spend 4 hours of your time really learning it.
So the interesting thing, another interesting nexus between you and I met Howard when he was on reserve duty, working in the DoD CERT, which at the time I was running. So it's really a small world in those activities. Miss him a great deal. So, Steve, thank you so much for being here today. It was really my pleasure to talk to you about your successes, your lessons, things that you didn't work out quite so well, and really the progress and focus on secure coding has been wonderful to see for us in the industry. If you'd like to learn more about SAFECode and what it's doing to identify and promote best practices for developing more secure and reliable software, hardware, and services, visit safecode.org. To learn more about the CERT Division and the work of our researchers at Software Engineering Institute, please visit our website. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.